Good afternoon, all. Welcome to fourth discussion session of the course Strength of Materials, course offered by NPTEL. The course instructor of this course is Professor Sriman Kumar Bhattacharya, is a professor from IIT Kharagpur, and myself, I am Asif Raza. I am a TA. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So, since it's fourth week of the discussion session, we'll be discussing questions relevant to assignment number 4, and its due date is still not over, so we'll not discuss the exact assignment but the questions relevant to it, and if time permits we'll discuss actual the assignment solution of assignment number 3 or maybe previous assignments also. If you have any doubt, you can ask like whatever question you feel that you still need more clarification regarding that. And uh, um, for your all information that to use the discussion forum as much as possible, it's for you all only. You can type in your doubts in that Google forum, and then we can have a discussion on it. Okay, so we'll start our session. Let us start with a light question, and I think this question was given in assignment number 3 also. So the question is, I don't know if is question visible to you. Okay, so the first question is, a bar with circular cross section having modulus of elasticity E, length L, and cross sectional area A is fixed at one end and free at other. If it is subjected to a temperature rise of delta T, the stress induced in the system due to temperature, considering alpha is the coefficient of thermal expansion, is option R E delta T, option B is L alpha delta T, option C is 0, and option D is E alpha delta T upon A. So yeah, it's best because since your audio is feeble, I cannot hear you, so you can type in the chat box whatever option you feel is correct. Yeah, you can. Murlidhar. So meanwhile I'll explain the question. We are given with a bar with a circular cross section, and it is fixed at one end and free at other end. It's having length L and modulus of velocity as E and area of cross section as A. Now we uh, increase the temperature by delta T in this system. So what would be the stress induced in the system? And according to you, stress in the system should be option A. Okay. Let us see. I can give the answer directly, but we can eliminate the options also. So first of all, let us see option B, whether it would be correct or not. So if you see option B, dimensionally, it's the question asks stress, right? And stress unit would be kind of megapascal or Newton per mm square or something like this. Okay, and if you see L alpha delta T, L has a unit of L has a unit of length. Alpha delta T would be kind of a dimension less, so its dimension would come out to be kind of a meter or millimeter, something like that. So but dimensionally also we can say this would be a wrong option. And let us see about option D. And option D, if you see, the units will come out to be, so alpha delta T won't have any dimension, then E upon A, so that would give me kind of megapascal upon mm square. and that is also dimensionally not correct. So option D would be wrong. Now E delta T, if you see, E has a unit of megapascal, and delta T would have a dimension of like Kelvin or degree Celsius. So this is also wrong. Megapascal times Kelvin or megapascal times degree Celsius, that would also be wrong. Uh, and the way I'm proceeding is just dimensionally. So with the elimination of the option, correct answer should be option C. Now let us see it through the conceptual thing. How would it be like stress induced in the system would be zero. So when temperature is changed in the system, suppose temperature is increased by delta T in the system, so this body will expand, suppose by delta L, and what would be this delta L? This would be equal to L alpha delta T. Yes, and if you see, this is restricted from one end and other end is free, so there won't be any restriction of the expansion of the system, and since there won't be any restraint, so there won't be any stress induced in the system. It can expand freely as much as possible with this delta T, kind of like this. The expansion would be L alpha delta T. So since there is no restraint, stress induced in the, like, since the bar is free to expand, the stress in the system will be zero. Okay. So I think it is clear from both ways, like dimensionally as well as from conceptual. Okay. Okay. Now let's uh, move on to the next question. Priyanka has joined a bit late, so you can see this question, and I think this question is already there in the assignment number 3, so there won't be any issue to this question. So we'll move on to the next question. Question number 2 for today's session is the determination of temperature induced stresses in an axial bar with fixed end subjected to temperature variation is. Now options are statically determinate problem, option B is statically indeterminate problem, option C is ill conditioned problem, and option D none of the above. So the question says we are given with the bar and it is restrained on both sides, and we increase the temperature, suppose delta T. So this problem would be statically determinate or indeterminate or ill condition. It's a ill condition problem or none of the above. Option B. What about Muralidhar? I hope you guys know what is statically indeterminate, because we discussed this question in abundant in the last session. Yeah, so yes, correct answer is option B, as in uh, the number of equilibrium equations and the number of unknowns won't be equal in this. So the number of unknowns is greater than number of equilibrium equations. Okay, that's why it's a statically indeterminate problem. Okay, moving on to the next question. This was a straight.
Sir,
Yeah.
sir, in such kind of problem, we use geometric compatibility, no, sir.
Yes.
So,
Yeah.
for different problems, how will we get to know like this is what we should apply, like geometric compatibility?
Uh, that differs from question to question, and like as in trust, the way to solve the statical indeterminacy is different as in comparison with frames or bars. So to pinpoint how to do for a particular problem, to generalize it, it's a bit difficult to say. But normally what we say, like if this case arises, we say that we need to satisfy strain compatibility condition. Strain compatibility condition, and that is what you also mean by, I think, geometric compatibility, where uh, uh, when we solve it, suppose I take a say element and element, like I discretize it and solve it element wise. Suppose let us take this system only and we solve it kind of like this. So we have various elements with this. Now uh, so there would be displacement here, 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 say. So the displacement, uh, uh, the value of displacements at this point and this point, it should be compatible so that cracks won't develop or interpenetration doesn't happen. I mean to say, suppose this point, uh, let me say A, B, and this is C, D. So if UB is greater than UC, so what will happen is there would be kind of interpenetration, and if UB is less than UC, uh, gaps would develop in the system, and so we want it to be like UB equal to UC. This is just one condition, like in the displacement wise we are saying. So we say in the strain compatibility equation there are 6 set of equation which would satisfy all the conditions which are required for the problem, for a particular problem. So I think it's a advanced topic, so if you want to study in detail, you need to do further study regarding this.
No, like sir in like regular class and all, he like solved some problems using geometric compatibility. So like usually how we use formulas and all, I thought like that it is there, or we should solve like more number of problems to get it.
Okay, I didn't go through the classroom lecture, so I don't know pertaining. Can you like specify what was the problem?
Like certain like in one problem what he did was like he used similar triangles for a rigid bar, like to find force. There was a bar which was hanging using cable, so to find the force in the cable he used similar triangle method deformation.
Okay, is it like symmetry or something like that?
No sir, he took like it will like it will remain rigid, but he told it will bend but it will remain rigid, it will like be inclined while deforming. So he used similar triangle for deformations and all.
Okay, I got your point. Okay, so let me see. Kind of like this kind of problem, or uh,
Ah
okay,
yes sir, similar to that sir,
similar to, okay.
just like that.
Uh, there's a question there was there. Okay, so suppose a force P is applied here, and A, B, C, D. and let us say O here. So we need to find what would be if length OB, BD all are given, and we want to find what would be the uh, stresses in AB and CD, right?
Yes.
So in this question, yeah, so the condition, the further condition is introduced in this system is they would say this bar is rigid. So with that, what would happen if we are considering it a rigid system? So if it displaces, like when this force will act on it, it will displace, because since it's a rigid system, it will displace, uh, being a hinge system, being mm, being a hinge system, it will just rotate here, right, from this
Yes.
hinge point. So if it rotates, like due to the application of force, it will displace downwards and displace downwards. So it has to maintain its rigidity. So the displacement of these bars would be such that, like if I, so it would be kind of like this, and this would be say delta B and delta D. So since it's a this and this will kind of give me a triangle thing. So if I say OB and D, so delta B upon delta D would be equal to OB upon OD. So this is kind of the extra equation which we are getting to solve this statically indeterminate structure.
Yes.
So so you wanted more like what will what kind of questions, or
No, sir. I like just asked because uh, while solving while solving problems like to other reference book and all, like there are different kind of problems. So we should
yes, yes,
approach in different way.
yes,
So
yes.
is it like we should solve more and more problems to know that, or is there something like trick or anything like that?
No, 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 no. You have to be aware of different kind of problems. It's best to have a different variety of problems, so that you have an idea to solve it. There is no formula, special formula pertaining to solve all kind of statically indeterminate problem. So, like we'll solve this question in like in the future, today only. Uh, okay, if it's needed, we can solve it right now. Okay, so with that we can like see how that statically indeterminate, uh, we can develop one extra equation through the geometric compatibility part. Okay, so let's solve this question so that you may get more clarity on this. So the question is, a rigid block ABC weighing 200 kilonewton is supported by three rods symmetrically placed as shown in figure given below. The lower ends of the rods are at the same level before the block is attached and temperature is changed. Assuming the block to remain horizontal, the stresses in steel and bronze rod respectively after a temperature rise of 20 degrees Celsius will be, and these are the given data where area, length of the steel, Young's modulus of the steel, and coefficient of linear expansion for the steel as well as for bronze are given. We need to find what would be the stresses in the steel and bronze rod. So if you see, uh, study the question properly, so here the main the thing which you need to see for the uh, extra equation to develop is here. This statement says, assuming the block to remain horizontal even after the temperature is increased. Normally, what would happen if the block was not there? If we increase the temperature, this would expand freely, and this would expand, this would expand. Need not be like both, all the three would expand equally, but the the given statement says block remain horizontal. Initially they are horizontal, it is horizontal, and after the application of the load and the increase of the temperature, the block remains horizontal. So we need to see how would we get that extra equation. Okay, so let's see. So what will, let's do this. Okay, so to do this, uh, yeah, okay. So let's see. Stresses in steel, both the steel, since it's a symmetric thing, we can assume the stress in the both the steel section would be same. So uh, sigma s would be same, and sigma b, let us be the stress in the bronze. Okay, so using force compatibility, like in the equilibrium, when after the uh, in the equilibrium, the forces would balance this 200 kilonewton, right? So what I mean to say is sigma s times as, and that is like 2 times, because 2 steel sections are there, and sigma b ab. So this would give me what? Forces which are acting opposite. Okay, and this would balance this weight. So this would be equal to 200 kilonewton. So I used to write it in terms of newton. So 200 times 10 to the power 3 newton. Okay, so this is one equation. Another equation we need to see is uh, due to this stress there would be extension, right? And due to temperature there would be again some extension to this. So total extension of the system delta T would be due to the stress as well as due to uh, stress and due to temperature. uh, I'll just write it total. Okay, and uh, so uh, this total extension, like to for the bar, horizontal bar, to remain horizontal, this total extension delta total should be same for steel, bronze, right? That means like delta total in steel should be equal to delta total in bronze. Okay, and that would be due to the stress in steel and temperature increase in steel. Similarly, stress in bronze and temperature increase in bronze. Okay, now uh, so uh, what would be the extension due to stress? It's sigma s upon es times ls, right? This is sigma es delta. Yes, this would be the extension in steel due to the stress, and uh, due to the temperature it would be ls alpha s delta t, right? Now similarly, in the case of bronze it would be sigma b upon ev times lb plus lb alpha b delta t. This would give me second equation. So if you see, we have two equations and two unknowns. Unknowns are sigma s and sigma b. Rest all we know. So let us substitute everything and solve it. So from 1 sigma b is equal to 2 into 10 to the power 5 minus 2 sigma s as is 1000. So 10 to the power 3 upon AB. AB is 1500. So 1.5 into 10 to the power 3. That would be equal 2 minus 2 sigma 200 minus 2 sigma s upon 1.5. Okay, let this be one equation. And substitute into, so sigma s, ls is 1 meter, so that is 10 to the power 3 mm. Es is 205. It's in kilonewton per mm square, so we can write 10 to the power 3 Newton per mm square plus ls. ls is 1 meter, so that is 10 to the power 3. Alpha s is 12 into 10 to the power 6 minus 6. Delta T is 20 degrees Celsius, so it will be equal to 20 equal to sigma b. Sigma b is this expression, so 200 minus 2 sigma s upon 1.5. LB is 1.5 into 10 to the power 3 upon EP 82 into 10 to the power 3 plus LB is 1.5 into 10 to the power 3 times alpha b is 20 into 10 to the power minus 6 times 20. That would give me sigma s upon 205 plus 24 to 40 into 10 to the power minus 3 equal to 200 minus 2 sigma s. I can write 100 minus sigma s 3 2 upon, this would give me 41 plus 1.5 into 10 to the power 3. This gives cancel out 10 to the power minus 3 and 20 20 400, so that would be equal to 600 into 10 to the power minus 3 implies sigma s upon 205 plus sigma s upon 41. This is 100 upon 41 and this would be equal to 600 minus 240 for 360. So this is 100 divided by 41 plus 0.36. This would give me sigma s as 2.799 divided by 2. 205 into 41. Okay, so answer for this is 95.633 megapascal. So consequently, sigma B would be equal to, using this equation, so 200 minus 2 times 95.633 divided by 1.5 minus 200 divided by 1.5, that would be equal to 5.822 megapascal. So some kind of could be round of error. Let me see, 200 minus 2 times 9.5 95.633 divided by 1.5, 5.822. So it's closer to option number B. Okay, 95.3 is it 100 by 41 6. Okay, so there could be some round of error associated to this. So our answer is closer towards option B. So I hope you got the idea for in this case, like what is the extra equation we are getting. So one equation we are getting through the force balance, balancing the forces in the steel and in the branch with the external load applied, and other is with the strain compatibility, and in that case the total strain in the steel would be equal to total strain in the branch, so that the uh, rod would be horizontal. There won't be any inclination pertaining to this. So I hope this is correct and resolved. So let's get back to the questions which we were discussing earlier. Okay, so the question number 3 for today's session is: for a system with plane strain condition, the number of strain components are, and the options are: option A is 2, option B is 3, option C is 5, option D is 6. So in the case of plane strain condition, how many strain components are there? I hope you know what are the strain components. Total: epsilon xx, epsilon xy, epsilon xz, epsilon yx, epsilon yy, epsilon yz, epsilon zx, epsilon zy, epsilon zz. Priyanka is saying option D6. I would reiterate, this is a plane strain condition. Yes, answer should be option B3. And why is it so? Like generally, what would be the number of? If I ask you, what would be the number of strain components? It's 6, as in y, uh, epsilon xx, epsilon yy, epsilon zz. And if you see this, you might be seeing there are 9 components, but effectively it's only 6 components, because epsilon xy is equal to epsilon yx, epsilon xz is equal to epsilon zx, and epsilon yz is equal to epsilon zy. So normally, let's say 3D case, 6 components, but for plane strain condition, let's say we talk about only xy plane, so the components remaining would be epsilon xx, epsilon yy, uh, epsilon zz would be 0. Like all the z components make it 0, so this would be equal to 0, this would be equal to 0, this would be equal to 0. So we'll be left with epsilon xy equal to epsilon yx. So these are the 3 strain components which would remain. That's why correct answer would be option B, 3. Okay. Moving on to the next question. So this is similar to if you guys have studied uh, uh, in the stress case. So question is, we are given with epsilon xx, epsilon yy, epsilon xy. Determine the axial strain at an axis inclined at 30° anti-clockwise from x-axis. So if you guys remember in the stress case, we used to resolve, we used to find normal stress and shear stress at a particular inclined plane. This is similar to this. There is just uh, transformation from stress to strain. So let us solve this. So original axis is xy and we want to find strains at this x dash y dash plane. So given data is epsilon xx is equal to 100 into 10 power minus 6, epsilon yy is 50 into 10 to the power minus 6, epsilon xy is 20 into 10 to the power minus 6. Okay. Now we want to find strains at x dash. Okay. So this would be equal to, if you remember the formula for resolving strains at a particular inclined plane. So this is equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus epsilon xy sin 2 theta. Okay, and for the given problem, theta is equal to 30°. So let's find this epsilon x dash, and this would be equal to 100 plus, I'll just take 10 to the minus 6 all throughout outside. Okay, 50 by 2 10 to the power minus 6 plus 100 minus 50 by 2 cos 2 theta, that is 60° plus epsilon xy 20 sin 60, and this is 10 to the minus 6, 150 by 2, that is 75, this is 50 by 2, that is 25, cos 60 would be 1 by 2, and 20 sin 60 would be root 3 by 2. So this would be equal to, so we can see from the option itself that this would be greater than 75 into 10 to the power minus 6, and out of all the four options, option D is greater than 75 into 10 to the power minus 6. Anyway, let's calculate it. So 75 plus 12.5 plus root 3. So this is 10 to the power minus 6 into 104.82. Yes. Okay, so answer is option D. I hope no issues pertaining to this question. You guys can like ping anytime wherever you feel doubt. Moving on to the next question. At a point in a loaded member, a state of plane strain exists, and the strains are epsilon x is given, epsilon y is given, and gamma xy is given. If the elastic constants mu, Poisson's ratio, and uh, G, shear modulus, is given as 0.25 and 80 GPa respectively, the normal stresses sigma x, sigma y respectively are. So, okay, so it's best to engage you all. So we're given with the quotient epsilon x as 270 into 10 to the power minus 6, epsilon y as 90 into 10 to the power minus 6. No, it's actually minus 90. Yeah. And gamma xy as 360 into 10 to the minus 6, mu as 0.25, and g as 80 GPa. 80 GPa, I'll write it 10 to the power 3 MPa. Okay, so we need to find what would be sigma x and sigma y. Okay, so can any one of you like unmute yourself and let me know how would you proceed?
What's up?
Like how would you solve this question? Uh, I, at the end I will solve it, but let me know how would you what would be your approach to solve this question?
So first we'll find E.
Okay, nice. That is through this formula, right?
Yes, sir.
Okay.
Then I will use the strain, stress and strain relationship, sir. Sigma x by E, epsilon x is equal to sigma x by E minus mu into sigma y by E.
And
Sigma z is 0, so minus mu sigma z by E.
why would that be zero? It's a plane strain case, not the plane stress case. It could be, right?
Okay, sir. So plane strain, okay, sir.
I'm not sure. So let's solve this. Similarly, epsilon y would be equal to what? Sigma y by E minus mu sigma x by E minus mu sigma z by E, and epsilon z would be equal to sigma z by E minus mu sigma x by E minus mu sigma y by E. But since it's a plane strain condition, this would be equal to 0. So we'll have sigma z by E equal to mu by E sigma x plus sigma y. I hope my approach is correct. Let's substitute this here. So our epsilon x would be equal to sigma x minus e minus mu sigma y by e, and minus mu square by e sigma x plus sigma y. Then this is sigma y by e minus mu sigma x by e minus mu square by e sigma x plus sigma y. We need to find sigma x and sigma y, right? So let's solve this. Okay, let's see this. So first let us take e epsilon x. This thing is sigma x minus mu sigma y minus mu square sigma x minus mu square sigma y, that is equal to 1 minus mu square sigma x minus mu 1 minus don't jump, let's see, mu plus mu square sigma y e epsilon x. Similarly, e epsilon y would be equal to 1 minus mu square sigma y minus mu plus mu square sigma x. Solving this, how to proceed? So multiply 1 minus mu square e okay, mu plus mu square e epsilon x and 1 minus mu square e epsilon y. So this would be equal to, so this and this cancel out, that will be equal to minus mu plus mu square whole square sigma y and plus 1 minus mu square whole square sigma y. The sigma y is mu plus mu square e epsilon x plus 1 minus mu square e epsilon y divided by 1 minus mu square whole square minus mu plus mu square whole square. I don't know if I'm doing correctly. Let's see. Mu plus mu square, I'll just take es out, resolving the denominator. So 1 minus a square minus b square, this would be a plus b into a minus b, that is 1 plus mu, and this would be equal to 1 minus so this would be equal to 1 minus a plus b mu square a minus b, and this would be equal to minus 2 mu square. I think this could be a mistake. This should have been my general approach. Okay, let's resolve it more. 1 plus mu. What can we do with this? 1 minus mu minus 2 mu square. Can we write it? So the first thing here, I can take mu as common, so mu 1 plus mu epsilon x, and this would be 1 plus mu 1 minus mu epsilon y. If I can take 1 plus mu here common, what else can be there? 1 minus 2 mu. Is there 1 minus 2 mu plus mu? Yeah, it's correct then. So E upon 1 plus mu 1 minus 2 mu times mu epsilon x plus 1 minus mu epsilon y. This is sigma y. So similarly, sigma x would be equal to what? E plus upon 1 plus mu 1 minus 2 mu epsilon y plus 1 minus mu epsilon x. So I think this would be the way. So let's substitute it and find it. What would be the answer? So we are given with E sigma x sigma y. Let's find sigma x. So E is okay. Let's find E first. So E is equal to 2 times 80 into 10 power 3 1 plus mu. 1 plus mu, that is 0.25. This would be equal to, so 1.25 into 25 40. So this would be 2 into 80 to 1.25. So this is 200 into 10 to the power 3 MPa. Next, epsilon x is 270 and epsilon y is minus 90. So this is 200 into 10 to the power 3, 1 plus 0.25, 1 minus 2 into 0.25, mu is 0.25, epsilon y is minus 90 into 10 to the power minus 6 plus 1 minus mu, that is 0.25, epsilon x is 270 into 10 to the power minus 6. Okay, so this will be equal to let's solve this. So 200 divided by 1.25 0.5 divided by 0.5, so this will be equal to 320 into 10 to the power 3 inside 94 minus 270 into 0.75. So this will be equal to 180 into 10 to the power minus 6, and this would be equal to 320 80 5 6 0 0 10 to the minus 3, that is equal to 57.6 MPa. Okay, similarly you can find sigma y also. Should I solve it with best I do this also? So that would be equal to E1 plus mu 1 minus 2 mu epsilon x 1 minus mu epsilon y, and that would be equal to this came out to be 320 into 10 to the power 3 mu 0.25 into 270 into 10 to the minus 6 plus 1 minus mu, that is 0.75 into minus 90 into 10 to the minus 6, and this would be equal to, so 0.25 into 270 minus 90 into 0.75. Okay, so this would be equal to 0 MPa. Okay, so sigma x is 57.6, sigma y is 0. Correct answer is option D. Okay, so Priyanka, I think like you must have seen where you were a bit wrong in this case. This is a plane strain case, so epsilon z would be there, no, sorry, epsilon sigma z would be there, but we would resolve those components into sigma x and sigma y, and again substitute in the equations here and then solve it. So uh, what if the question would have been the plane stress case? What approach would have been there? I think you can answer now.
Then sigma z will be 0, but we cannot say about epsilon z no, so that time.
Yes, so epsilon x would be sigma x upon e minus mu sigma y upon e, and sigma z would be 0, so we don't need to write sigma z by e. Okay, and epsilon y is equal to sigma sigma y upon e minus mu sigma z upon e. Epsilon z sigma z upon e, like this is kind of a general thing, but since sigma z would be 0, this would be equal to 0, so we can still find sigma z, but our point of concern would be only to find sigma x and sigma y, so these two equations would suffice to find what would be my sigma x and sigma y. Okay, so there won't be any need to find this, use this equation. Okay, so yeah, it's best to see what is the question. So yeah, the question was the case for plane strain, so you better look it carefully, because even if you know how to solve it, just a slight miss can give your answer abrupt. Okay, I hope it's clear for you all. Moving on to the next question. Okay, so this is a straightforward question. So for a physical system, the maximum shear strain coincides with the pure shear strains when, and the options are: the principal stresses are equal and opposite in direction. Option B is the principal stresses are equal in magnitude and same in direction. Option C is the principal stresses are unequal and opposite in direction, and option D is the principal stresses are both compressive. So you guys can give your guesses in the chat box. Priyanka is saying option A. What about others? Okay, Mallit has also said option A. What about Papia? Correct me if I am pronouncing your name wrongly.
No, sir, it's okay, Papia.
Okay, so what do you think? What would be the correct answer?
A, the principal stresses are equal and opposite in direction.
Yes, so I hope all the audience agree that correct answer would be option A. So if we draw the most stress Oh, sorry. So Mohr circle pertaining to this case, so it would be kind of this, where this is this would be kind of epsilon xi, I'll just say epsilon, and this would be gamma by 2. Okay, so the principal, okay, so if you see, the principal stresses are equal and opposite direction. Okay, so the here it should be equal to strains also. It could have been strains also. So if principal strains are equal, that means like epsilon 1, and this I am saying epsilon 2. So and this is uh, gamma by 2, and gamma by 2, that would be equal to gamma by 2 max. Okay, and this would be also gamma by 2 max. So gamma by 2 max, it's equal to epsilon 1 minus epsilon 2 by 2, and yeah, and this would be as in the case where epsilon 1 and epsilon 2 are equal in magnitude and in opposite direction. Okay, so answer would be option A. Similar to this question, I'll just ask you on okay, so this is the question. In the Mohr circles for strain, diameter of Mohr circle represents. So what would be the correct option? Option A is maximum shear strain, option B is twice of maximum shear strain, option C is minimal normal strain, and option D is maximum normal strain. And I thought you guys would make mistakes, so let's see. Priyanka said option A. Muralidhar said option B. What about Papia? So we have one from Priyanka as option A, one from Muralidhar as option B. Papia, you can guess anything you see correct pertaining to this. Are you there? I think I don't know. Okay, so this is a tricky question. If you remember, Mohr circle for stress, it was normally sigma upon sigma and tau axis, right? And in that diameter, the radius of Mohr circle would represent kind of maximum shear strain. But in this case, it's a case for gamma xy by 2, right? uh, Gamma xy by 2, so this would be gamma xy max by 2 would be equal to epsilon 1 minus epsilon 2 by 2, and epsilon 1 minus epsilon 2 is the diameter. Yeah, and gamma xy max should be equal to epsilon 1 minus epsilon 2. So answer would be A, maximum shear strain. So Priyanka is correct in this sense. In the stress case, normally it would have been like tau xy max. It was kind of sigma 1 minus sigma 2 by 2, and diameter used to happen like sigma 1 minus sigma 2. So in that case it would have been like d by 2, or twice the diameter would have been twice of 2xy max. But in the case of shear strain, diameter is equal to maximum shear strain. Okay, so this is a trick. Okay, let's again get back to the questions. Okay, so this is a question. A cubical element is subjected to sigma x equal to sigma y equal to sigma z equal to 5 megapascal. The shear strain at an angle of 30° anti-clockwise from x-axis is given G is equal to 90 GPa, and we have this following four options. So what do you guys think? What would be the correct answer? Oh, before that, like to guys give you in the right direction. Let me first ask you, what is this case called? Like in this case, sigma x equal to sigma y equal to sigma z is equal to 5 megapascal. So all of the stresses are equally valued, and uh, shear strain, whatever be the case, but equally valued sigma x, sigma y, sigma z, and in that case, sigma xy or shear strain or sigma leave that case. So sigma x equal to sigma y equal to sigma z is equal to 5 megapascal. What would be that case? Um, okay, I'm not framing the question properly. I was just asking, what is this case called as? It's a hydrostatic tension test or something like that. Yeah, hydrostatic condition. So okay, so leave that thing. What would be the correct answer pertaining to this? I would give you a hint, guys, hint to like see what would be the Mohr circle pertaining to this.
It will be a point, sir.
Yes. So for that shear strain, uh, so in this case, like the given condition, sigma x equal to sigma y equal to sigma z is equal to 5 megapascal, and the shear strains are 0 in this case. So if you draw the Mohr circle, taking any two planes, it will always give me a point at 5 comma 0. Now resolving at any angle, this would still be a point, right? So shear strain should be 0. Okay. Uh, yes. Okay. Mm, moving on. What is the volumetric strain for an isotropic material with Poisson's ratio 0.5? So rather than giving me the answer, I would ask you like, what your approach would be to this question. I should ask you all how volumetric strain is found. Any one of you? Yeah.
Sir, epsilon x plus epsilon y plus epsilon z.
Epsilon x plus epsilon y plus epsilon z. Yeah. Okay. Uh, but okay. Yes. Then.
Then, if we write like equation of epsilon x, epsilon y, then we will get it in terms of uh, Poisson ratio and stress. No, sir.
Yes, but we are not provided with stresses. We can express all the things in terms of sigma x and sigma y and E and mu. Okay, so you are saying, I'll just write those things. Sigma x, epsilon x is sigma x upon E minus mu sigma y by E minus mu sigma z by E. Similarly for epsilon y and epsilon z. When I write this thing, I'll get like this would be equal to 1 minus 2 mu sigma x plus sigma y plus sigma z upon A. Okay, if you add this all the equation, okay, sigma z upon E minus mu sigma x upon E minus mu sigma y upon E. Okay, let's substitute this thing. So 2 mu, so this would be equal to 1 minus 2 into yeah. Okay, oh, you're saying yes. So this thing becomes 0. So even though the values are not provided for this case, we can directly say it would be equal to 0. Okay, in this case, normally like strains are defined using some modulus, right? Like as in longitudinal strain. It was defined using modulus of elasticity, right? Stress upon E, right? So for the case of volumetric strain, what would be this? What would be the modulus called as? Do you guys know?
Bulk modulus.
Yes. So bulk modulus. So if you see this expression itself, bulk modulus is equal to no, it's not exactly this. It's actually 3 e by 3 1 minus 2 mu. So kind of sigma x plus sigma y plus sigma z by 3. 3 is converted into sigma m. So this would be kind of right. Yeah, kind of this way. So so kind of this would be equal to epsilon v times sigma m upon k. Okay. I hope everyone has no issues pertaining to this question. The correct answer to this is option D. Let's move on to the next question. Okay. Question is, we are given with a cubical element which is subjected to following state of stresses where sigma x, sigma y, sigma z is given and other shear stresses are given. Modulus of elasticity is 2 into 10 power 5 MPa. Poisson's ratio is 0.25. Assuming the material to be homogeneous and isotropic, determine the maximum shear strain. Okay, so since this is a long question, I would ask you all, like, what would be your approach? Think that Priyanka would be knowing, but I would ask others to take the initiative this time. Any one of you, like Murlidhar or Papia, anyone? Yeah, Murlidhar, come again. Yes, yes. So how? What would be your approach? What's the formula to find the shear strength in any direction? Say tau. If I want to find tau xy. Sorry, question was wrong. Tau xy max. Yes, maximum shear strain. So uh, so what if I ask you what would be tau xy max? How would you find it? Uh, if you are speaking anything, I cannot hear you, Murlidhar. Still not audible. Papia, can you take up on this?
Sorry, sir, I can't.
Okay, no problem. What about Priyanka? I hope the question is clear for you all. We are provided with the stress component sigma x, sigma y, sigma z, and shear stresses. We need to find the maximum shear strain.
So, um, using the principle sigma x minus sigma y by 2 whole square plus tau xy square,
Mm,
root of that one.
okay. Okay. Since if you see tau xy, tau yz, and tau zx is equal to 0. So this is kind of a principal stresses, uh, if you may. So kind of sigma 1 would be equal to 80, sigma 2 is equal to minus 20, and sigma 3 is equal to minus 30. Okay, so uh, I could give you directly maximum shear stress would be sigma 1 minus sigma 3 by 2 tau max, right? And that would be equal to 80 minus 30 by 2, and that would be kind of 110 by 2, that is 55 MPa, right? And to get this gamma uh, max by 2, uh, that is equal to tau max by 2g, that is gamma max by tau max, and that is 55. 2 cancel out, so only g is e uh, e by
So,
2, 1 plus mu. Yeah, tell me.
no, sir, like I saw gamma max by 2 is equal to, no, sir, 2 got cancelled. That was my doubt.
Okay,
Nothing,
okay,
sir.
okay, okay, no problem. just write it properly for you. Okay, so this is equal to E is 2 into 10 to the power 5 to 1 plus 0.25, right? So to cancel out, here it's 1.25, that means 5 by 4, that is 4 by 5, 0.8 into 10 to the power 5. So 0.8 into 10 to the power 5 megapascal. Yeah. So this would be equal to 55 55 divided by 0.8, 68.75, that is 6.875 into 10 to the power minus 6. So this is the direct answer. So answer would be option D. Okay. Normally, what I feel, normal approach is what Priyanka was saying. I think is first we need to find the sigma 1, sigma 2, and sigma 3. To do that, uh, need not be uh, you guys can find sigma directly tau max by, like, if it had not been 0, tau xy, tau yz, tau zx was not 0, we cannot use this formula directly. So to uh, find this, we need to find for all the direction. So we need to find in the direction of xy, that is tau xy max, and that would be equal to root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay. Similarly, in the case of yz, tau yz max equal to sigma y minus sigma z by 2 whole square plus tau yz square, and xz plane, that is tau xz max would be equal to sigma x minus sigma z by 2 whole square plus tau xz whole square. And after finding whichever is the maximum, you just need to uh, substitute maximum of tau xi max, tau yz max, tau xz max upon tau max. So gamma max would be equal to tau max upon G. Okay. So I think what Priyanka was saying, I think it was pertaining to this direction. Is it, Priyanka?
Yes, sir.
Yeah. Okay. So yeah, your approach is quite correct. But in this case, since shear stress, shear stress at 0, so the stress values which are given are principal stresses. So we can directly find the normal, tau max easily. So no need to go through the pains to find the square root and all. Okay, I hope this question is clear for you all. Let's move on to the next question. Okay, this is a different genre. The question is, during a test of an airplane wing, the strain gauge readings from a 45-degree rosette as shown in the figure are as follows. At gauge A gives value this, gauge B gives this, and gauge C value gives this. Determine the principal strain values. So we are given with like 45-degree values rosette, and this is at A, B, C. I'll just like without wasting time, I'll just tell you all. Epsilon A and epsilon B since kind of in x and y direction. So sorry, epsilon A and epsilon x would be equal to epsilon A, and epsilon y would be equal to epsilon C. Okay, that is equal to uh, 7 into 10 to the minus 6. This is equal to 4 into 10 to the minus 6. To find gamma xy, that would be equal to 2 times of epsilon b minus epsilon a minus epsilon c, and that would be equal to 2 times of epsilon b is 2 into 10 to the minus 6 minus 7 into 10 minus 6 minus 4 into 10 to the minus 6, and this would be 4 minus 7 into 10 to the minus 6, and yeah, okay. So since we know epsilon x, epsilon y, gamma xy, to find principal shear strain, that would be equal to epsilon x plus epsilon y by 2 plus minus epsilon x minus epsilon y by 2 whole square plus gamma x y by 2. Don't forget y here. Okay, more this case by 2 whole square. So just substitute the values. So this would be equal to 7 plus 4, 11 by 2. And 7 minus 4, that is 3 by 2. That would be 9 by 4 into 10 to the minus 12. Then gamma xy is minus 7. So even though minus, that won't affect. So minus 7 by 2, 3.5, or just write 49 by 4 to the minus 12. Okay, this would be equal to 5.5 plus minus 9 by 4 root 58. Let me see, fine. Root 58 is this by 2 plus minus 3.808 10 to the minus 6, and this would give me values plus 5.5. This would be equal to 9.308 10 to the minus 6, and minus 2 into 3.808, 1.691, I think. Yeah, so with that, option C matches. Okay. Okay, moving on to the next question. This is quite an interesting question. So we are given with a displacement field in terms of function of x, y, z. So this is the function of the displacement field. So we need to find what would be the shear strain at point 1, 2, 0, and these are all pertaining to kind of gamma xy, gamma yz, and gamma zx things. Yeah, I may be wrong, that would be in different direction also, but let's see. Any one of you, like what would be your approach to find gamma xy? Just let me know. Any one of you can raise hands and like speak.
Sir,
Yeah.
in the displacement field, it is given epsilon x, epsilon y, and epsilon z.
No, it's a displacement field. Yes. U is 3y square I plus 6yz j plus 5 plus 8x square k into 10 power minus 2. Just forget, okay, leave it. So I'll help you in this regard. So uh, if you see, this is I Z K. So kind of in the displacement, we are provided with the direction. What would be ux, uy, uz? Kind of ux is given 3y square into 10 power minus 2. Uy is given 6yz into 10 power minus 2, and uz is 5 plus 8x square into 10 power minus 2. So displacement values are given, not the strain values. But we need to find the strain. So now, what would be your approach? Gamma xy, you know the formula, I think. When we are given with the displacement fields, how do you find the strains? Shear strain.
Don't know, sir.
Okay. I'll help you in the normal stress. Let's see if you catch it to the shear strain or not. Epsilon x is del u x by del x. Epsilon y is del u y upon del y. Epsilon z is del u z upon del z. Do you know this formula?
No, sir.
Okay. I think you should know. So gamma xy is, like shear strain is found using this formula: del u x upon del y plus del u y upon del x. Similarly, gamma yz is del u y upon del z, del u z upon del y, and gamma zx is equal to del u z upon del x plus del u x upon del z. Okay, let's solve this. So what would be dou u x upon dou y? This is, so this would be equal to 6y into 10 power minus 2, and dou uy by dou x is 0 because it's just a function of y and z. Okay, so this is equal to 6y into 10 power minus 2. What would be gamma yz? Gamma yz is dou uy upon dou z. So this is equal to 6y, right? We take this and differentiate with respect to z. So this would be 6y into 10 power minus 2, and dou uz upon dou y, uz upon dou y, that would be equal to 0. So again this would be 6y into 10 power minus 2, and those gamma zx, dou uz upon dou x, and this is 8 to 16x into 10 power minus 2, and ux upon z, that is equal to 0. So again 16x into 10 power minus 2. Now we need to find all the strain values at this point P, that is 1 comma 2 comma 0. So strains at P is 1, 2, 0, that is x is equal to 1, y is equal to 2, z is equal to 0. Substitute this. So gamma xy at P is 6 into 2 into 10 power minus 2, that would be equal to 0.12. Gamma yz at P is again 6 into 2 into 10 power minus 2, that would be equal to 0.12. And gamma zx at P would be equal to 16 into 1 into 10 power minus 2, that is 0.16. So answer is 0.12, 0.12, 0.16. So answer is this. Okay. In addition to this question, like we can the question people who are setting the question can ask you, these are shear strengths, right? And these are the expression pertaining to the normal strength. Sigma epsilon x, epsilon y, epsilon z. They can ask you what would be the volumetric strain at point P1, 2, 0. So that would be equal to, like we have already discussed. You can just tell the expression.
It will be sum of the above three, no, sir?
Yes, yes. So that would be just this. Okay. So it's best to keep this in mind, this one and this one, because these are like vividly used in further studies. So it's best to keep these expressions in mind. And like only two of this and one of this is sufficient, because by the use of change of the symbols you can get the other formulas also. Okay. Moving on to the next question. This we have already solved. Let's move further. Okay, so like let us do a light-hearted question. Uh, the, the bulk modulus of elasticity of a material is twice of its modulus of rigidity. The Poisson's ratio of the material is. So, okay, I'll give you guys a bit of time and let me know what would be the answer pertaining to this, because you guys can do this quite easily. Just to give you a hint, earlier we discussed two formulas, right? Uh, 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 in bulk modulus in terms of Young's modulus and Poisson's ratio, and that was K is equal to E upon 3 1 minus 2 mu, and we know the expression for G is 2 1 plus mu. Okay, Priyanka has already come up with the answer as option B. That's nice. So we are given with the question is the bulk modulus of elasticity of a material is equal to twice of its modulus of rigidity. This is the question. So just substitute this formula here, and let's see. E 3 1 minus 2 mu 2 E 2 1 plus mu. So E cancel out, 2 cancel out. So that is 1 plus mu is equal to 3 minus 6 mu, and uh, this will be 7. So mu equal to 2 by 7. Yeah. Yes. Nice. So answer is option B. Okay, this is quite an easy question. Let's move on to the next question. I hope you guys will correct this question. So we are given with the two principal strains at a point are 100 into 10 power minus 6 and minus 200 into 10 power minus 6. Then the maximum shear strain is. So we are given with epsilon 1 and epsilon 2. We need to find gamma x. I'll just write gamma max. Guesses? Okay, no need to guess, directly answer. Okay, I thought so that you guys would make mistake pertaining to this. So Priyanka said option A, Amulidhar said option C. So like we discussed earlier also, if you remember this part. So epsilon 1 minus epsilon 2 is gamma xy max, and tau xy max is actually sigma 1 minus sigma 2 by 2. So since this is a strain case, uh, just like see, gamma max by 2 would be equal to epsilon 1 minus epsilon 2 by 2. This would give me gamma max is equal to epsilon 1 minus epsilon 2, that is equal to 100 minus 200 to 10 power minus 6. This is equal to 300 into 10 power minus 6. Okay, the answer is option A. So that's why I told you, like in the expression to find uh, this maximum thing also, I told you all to notice this by 2 here. Okay, this is a very like slight change in the formula as comparison to the stress. Okay, so you better see this carefully. There's a by 1 upon 2. Okay. Mm, that's why it's not 150, it's actually 300 into 10 power minus 6. Okay, moving on to the next question. This is also similar. I hope you won't make a mistake in this case. You are given with epsilon x, epsilon y, gamma xy. Need to find associated principal strain values. So let's see if you correct this time. Give me the values for uh, epsilon 1, epsilon 2 and gamma xy max, all the three. Okay, let me solve it. Show. Okay, so Priyanka has already come up with the answer as option A. What about before I find what's your gamma xy max? Priyanka, oh, you're still finding. Okay, 900 by 2 plus minus 100 by 2. Okay, maximum shear strain is 1063 into 10 to the minus 6. Let me do this. So this is equal to 49 plus 64. This is root 113. So 10 to the minus 6. So 50 plus minus 250. 531.507. Yeah, so epsilon 1 is equal to, if I take the plus, so 450, that is 981, yes, into 10 to the minus 6. Epsilon 2 is, if I take the minus 1, this would give me minus, so minus 531.507. Minus 81.5. I can just write this, and gamma xy max is, we can just write it like this also, or you got this one, right? So you just double this one. So rather I'll just add this thing. So 981 minus 81, so kind of 1062 into 10 to the minus 6, so kind of a round off error or something like that. So yeah, it's nice. Option A is the correct answer. Moving on. Okay, so this is the question which we are coming across like again and again. So given that for an element in a body of homogeneous isotropic material where epsilon x, epsilon y, and epsilon x z are normal strains in x, y, z direction respectively, if mu is the Poisson's ratio, the volumetric strain will be. Yeah, so as I hope Priyanka is already with the answer. So like we have said this formula like almost 3 times. So answer is option A. Volumetric strain is given by this relation epsilon x plus epsilon y plus epsilon z. Okay, let's move on to next question. So we're given with a copper wire of 25 centimeter length is fixed by means of support at its end. Supports can yield by 0.01 centimeter if temperature of the bar is raised by 100 degrees Celsius. Then stress induced in the bar for like alpha given value of alpha and E, and options are this. So it's kind of the thing which we need to do is compatibility thing only. So we are given with the question is uh, there's a copper wire of 25 centimeter length I'll write 250 millimeter in length, and is fixed by means of what supports at its end. And this, it says that supports can yield total by 0.01 centimeter. Okay, so kind of we can say uh, like it can like delta by 2, where delta is equal to 0.01 centimeter. I'll say max, delta max. They can yield maximum by this values. Okay, uh, that is delta maximum is equal to 0.001 mm. If the temperature of the bar is raised by 100 degrees Celsius, then stress induced in the bar is, so delta T is 100 degrees Celsius. We are given with the alpha as 20 into 10 to the minus 6 per degree Celsius, and E is 1 into 10 to the minus 6 kg per centimeter square. Okay, so in this case units is given in kg per centimeter square, that is it's a CGS unit. So I can convert length as in centimeter, and okay, let it be, I'll just keep this as kg per centimeter square, and I'll be careful about the dimension we are using. Okay, let us see. First thing, how much extension in length would be there if I increase the temperature by 20 degrees Celsius. Don't think about the supports now. My length is 250 mm copper, and then we increase the temperature by 100 degrees Celsius. So L alpha delta T is the extension it would be, right? That would be equal to 250 into alpha is 20 into 10 power minus 6, and delta T is 10 power 2, that is that is 0.5 mm. Okay, and see, if you see, if it had been allowed an extension, 0.5 mm, it would have extended in both ends, right? Let me see if I'm not making a mistake. 10 power minus 6 minus just 250. Yeah, so okay, this is 0.1 mm, right? So if you see, if it had been allowed to expand freely, it would have expanded 0.5 mm total, but the supports are allowed to extend only up to 0.1 mm. So after this, like bars will expand up to 0.1, and then it would not be allowed to expand more. So the body will develop stresses. So uh, uh, the stress amount would be equal to, so net extension is only this, right, uh, 0.1 mm, but body tries to develop 0.4 mm. So uh, 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 what I say, stress to account for the uh, the extension, it was not allowed. Stress would be generated in the system. It would be equal to just stress is equal to E times strain, right? E times strain, and in this case stress, E times strain would be, so this would be equal to E times 0.4 and kg plus, okay, 0.4 upon the length is 250, so this would be equal to E times 0.4 upon 250. This would be equal to 0.0016, and since this is a dimensionless quantity, so unit would depend solely on this, so we can directly substitute the values. 10 power minus 6 into 0.0016 kg per centimeter square, and this would be equal to 1600 kg per centimeter square. Okay, so this would be the answer. See, okay, let me say this thing properly once again. The total is due to temperature and due to stress. Due to temperature, it's allowed to extend by 0.5 mm, right? And total elongation it can occur is 0.1. So elongation due to stress, it would be kind of minus 0.4 mm, right? So stress would be equal to E times delta sigma upon length, and E minus 0.4 upon length is 250, and the same thing, so minus 1600 kg per centimeter square, that is compressive in nature. Okay, moving on to the next question. Probably the last question for today's session. Okay, so the question is, at a point in a loaded member, a state of plane stress exists, and the strains are epsilon x is equal to 217 10 power minus 6, epsilon y is minus 19 10 minus 6, and gamma xy is 316 10 minus 6. If the elastic constants nu and g are 0.25 and 80 GP respectively, determine the normal stresses sigma x and sigma y. So initially we solved for the plane strain case, if you remember. This time it's a plane stress case. Okay, so I'll leave this question to you all, because we have already we know how to approach this question, right? This was the case of plane strain. When we are given with the various strain values, we need to find sigma x and sigma y. So we had this approach, and I already told what would be the approach when the plane stress case is there. So we just use that approach and solve this. And I think it's best I'll leave you this question to you all only. It's just the sigma x upon E minus mu sigma, in this case it's nu, sigma y upon E and epsilon y is sigma y upon e minus nu sigma x upon e. To solve this, to find sigma x and sigma y. Okay. And I'll leave this question to you as well. It's best you guys do this as a homework. Okay, so it's almost past 6, so I'll wrap up the session here. I would ask you all, like, if you guys have any doubt pertaining to today's session or any question uh, regarding previous assignment, so you can ask before we wrap up today's session. And I would ask you all, like, you guys have received the link for the notes as well as for the uh, discussion session or recording of the discussion session, isn't it? Can anybody confirm? Yes. Okay. Thank you. Yeah. So, do you guys have any doubt pertaining to today's uh, session or previous assignment? So we can discuss for like few minutes. Nobody has doubt. Like normally this question, people try to mug up the formula, but I don't normally remember it. That's why I proceeded with what I normally follow, I the conceptual thing. So this is the way I do. Okay. uh, Come out less case, then yeah, train reset. So yeah, you guys better to see this thing. Yeah, it's by 2, right? So don't forget this one. They will make a lot of mistakes there. Okay, this one, this one, this one. This is frequency. Okay. Mm, uh, okay, so to inform you all, I won't be available for the next 2 weeks. So I don't know what would be the timing for my session, like for the upcoming 2 session. So I'll like post in the discussion forum, or I will write it in the description box of the session uploaded video. Okay. So like when would the next session be for me for the upcoming 2 weeks? I hope I am clear. So can we wrap up here? Okay, Papia has given affirmation. Yeah, thank you. Thank you all for joining. You guys can like post any of your doubts. I'd be more than happy to like resolve your doubts. Thank you. Okay, bye. Take care. And like I'll post it in the description or maybe in the discussion forum when the next discussion session would be. Okay. See you all whenever the next discussion session happens.
Okay, sir. Thank you.
Yeah, okay. Bye. Welcome. You're welcome. Bye all. Take care.